Hello, and we are live again. Welcome back to our YouTube channel, of Kotlin. Have you heard of Kotlin? Of course you did. It's me today again, Anton, and welcome back, Viktor.
Hello, everyone. It's great to be back. It's great that you folks keep inviting me, and yeah, it's gonna be a great show today, folks. We have a pretty cool stuff for you.
Pleasure. I'm excited too. All right. So this is the fourth webinar in our second series of webinars of Kotlin for the server side. And today we are talking about Kafka again, right? Kafka with Kotlin and Ktor, by the way, not Spring. Last time, folks were upset that we were using a lot of Spring magic, right? So we decided to bring Ktor this time.
Yes, today we're going to be demystifying, doing less magic. Yeah, will be more practical effects rather than the magic, right?
So we prepared a very nice demo for you. Viktor will go over this, but before we start, if you didn't see the webinar yesterday about Ktor, what the framework is and what kind of features it provides, I will do a brief introduction so that you know, like, we are not just using some sort of a obscure library or whatever it is, a new language, Ktor, what it is, right? So it's a Kotlin first framework, Kotlin first web framework. It actually provides a server-side component and a client. Client, by the way, is a multi-platform one, so you can actually target JVM, JavaScript, and even native with that. It's very popular in mobile development. But the server-side component is fully JVM. Maybe one day we will have it multi-platform as well and run it on a native platforms. But so far it's JVM. It's tightly integrated. It's very lightweight, too lightweight. Even while we were creating demo, so we realized that it's too flexible. Sometimes it actually, when you are used to using Spring, and with Spring you have all kind of recipes how to do things, and with Ktor you actually have to kind of convert your mindset a little bit and start, writing real code. All right, so there is a very nice documentation. We are going to use this framework for the demo. The framework provides a bunch of features. Like if you go to the documentation, there is a list of features for the framework, and we are using some of them, especially WebSockets integration on the server side. We have also WebJars integration, like so that you don't have to copy the JavaScript dependencies into your project. We are going to use WebJar functionality to download and serve those JavaScript libraries into the UI. What else did we use, Viktor? Do you remember? I think those were the two primary features. But of course, Viktor remembers we are using Kafka, and we created our own custom feature to actually install Kafka component into the application.
Yeah. So this is going to be, we will walk through the code and we'll show you what we did to make this work. And we try to do this like use the Ktor for this demo with like hate and passion, meaning that like we squeeze some of the will and push it on some of the boundaries from perspective of how the people or might want to use this in the real world. And if you would like, we do have this code already published in GitHub repository. So
exactly, I will share the link in a few moments in the chat, so you can click it and browse the code with us as you want. But I think we are ready to start. But before we do, probably just a show of hands in the chat. Where are you from? Why are you interested in the topic? Are you using Kafka or not? Are you using Ktor or not? Maybe you are using some other framework with Kafka, and please share. And I think we are ready to start, Viktor, right? So let's start with the demo. Let's show the awesome UI as this meme, like the UI, the front end and the back end. We'll first show you the nice picture, and then we move backwards. Like we go to the backend and show you the real picture.
So let me see. If I do have, I don't. Yeah. So my infrastructure right now is down. So that's why I will show like a quick bits here. So give me just one quick second. I will. You can share my screen. That's all right. I'll show what I'm trying to do for this demo. So that's why. So first of all, I would like to start this by talking a little bit about the microservice architecture and why it is. I think it is important. And after that, we will go into the bits of this talk. So when you start doing something, when doing some cool stuff from the very beginning, everything is nice and clean, and this is how you get the tools that allow you to generate nice clean structure, right, Anton? We can use some of the like start.ktor.io. We get the nice clean structure file location. We start getting some of the easy to understand bits of codes. We start adding some cool things. We start adding some of the functionality. We start adding some of the I don't know, like we're adding some more REST endpoints. We're adding more services. We're adding more integrations. We start adding databases. We start dealing with different type of databases. And as you can see, things getting a little bit darker now. So it's not like that new shiny thing anymore. Things getting even darker when you start getting new requests, and you can get new requests from your users adding some new functionality. You start onboarding new people into the project, and this is the people adding more code. Some code becomes obsolete. Some of the bits becoming obsolete. You can find some dead code there. Some of the tools can help you find dead code, but like you're so afraid to touch it because you don't understand what is going on there, because there's too many things are happening here. Like you're talking to your admin, you're talking to your architect, and he's trying to show how all different components interact together, right? This is where we're going into the world of the traditional enterprise software. So the only help here is that we started doing a couple of years ago is to do refactoring stuff using microservices. And microservices, it's essentially you disintegrate your application, and after that, once you disintegrate this, it was easy things to do, but like what you can do to make them work. So in the good old days, when everything was much more simpler, everything was one application, right? How many of you remember these times? Like we do have this like 3-tier Sun microsystem blueprint for Java EE. This is how you develop applications. So not anymore. So those applications are distributed. So but it's good. It's okay. It's like it's a normal application. It's a very easy things to think about this. However, when the things are getting more and more complex, you need to start like tearing your hair out of your head and getting really, really crazy about explaining people how this all works. So that's why why you need to explain people how to use it, because you need to make some changes in the system. You need to do stuff to integrate those services. And the hardest part is to, like, we broke down our monolith. It's not difficult, but like how we can integrate this together, how we can start exchanging the data. So this is actually not right. So there are good ways to integrate in microservices, but there are no good ways to integrate these microservices. So that's why we will talk about the few things that people might want to be useful, and you will understand why I'm talking to this in a few seconds. So file system. How many of you actually try to integrate two systems through file system? Like write down in the comments. It would be great to learn if someone actually did this in their system. But it's just not. It doesn't feel right. Yeah, it's just like it feels really, really wrong to do. Like one system writes file in the file system, another system will read this file. You can use how you would exchange information between systems that distributed. So you need to deal with these distributed file systems.
I remember sending messages using files through FTP.
Exactly. That's exactly how we were doing this while we were working on the big banks, right? We remember the landing areas that the file needs to be structured in a certain way. Someone will mess up with the name of the file, and everything will go to reprocessing, and you will not process some of the payments and things like that. Not cool. Not cool. So that's why people start saying, all right, so like we can enforce some of the rules. What about databases? Can we use database to exchange this information? Well, it's possible. It's a good thing to do, but there's a certain complications here. There's certain things that might work. You can say, yeah, Viktor, but we know databases. Everyone knows databases. We can just like have schemas for everyone. Like a SQL is easy, and everyone knows how to use it. That's true. However, once the services start using database as their things to exchange this information, more and more services, they're trying to pull the blanket to each other. They start some of the ideas from one domain will be like a leak into another domain. So this way we bring in this bounded context of one service into another context of another service, because all of a sudden your application needs to some changes, and multiple other applications will be affected. Database is still great to provide a persistence for your service, so it will be inside your bounded context where you have a control over the things, but it's not a good thing to communicate between microservices. It's incredibly difficult to agree about something once you start changing the schema and things like that. So, but we have remote procedure calls. It feels and looks the same as we're calling our code, because we break down monolith. We broke down those functions. One model calls another model. Like how we can, why we cannot use this? RPC is a good. It's a little bit better, but it also downsides because it requires some of the direct communications. You can agree upon API and the structure of the calls, and you can publish this. There's the ways how you can use intermediate frameworks. You can use like Open API. You can use gRPC to define the structure of the messages, define the structure of the services, and publish this so other teams will be using this, and it would be much easier to agree upon. And however, there's a very big problem with these systems. And the problem is dependencies and cascading failure. So if all your service will depend on one service that will depend on another service, and you will have a cascade of those calls, you might have a problem here. And how you would debug such a system? So like, Anton, how you debug such a system in this case? How you would figure out like which service causes some of the problems?
Well, you probably use some tools like Wireshark, install some network monitors, write the logs, Splunk maybe.
One of the things that I learned very early in my career, when I also started bringing some of the tools to debug some of the problems, one of the senior architects or senior engineers came into play and saying the best debug tool is system out println. So you're using system out println and writing the results of every service into console, and you're trying to follow. So essentially, you need a log, right? So you need the log file that you also mentioned, and which log? Like let's look on this log. So what kind of properties this log has? So first of all, we do see it has a date, so we know that the particular thing happened in particular time in particular place. We know where the thing happened. In this case, it's our class and the location in our code. We know where the thing happened. So the thing also is immutable, right? Because I don't know, like some of the hackery, and you're trying to change the logs and things like that. You actually not changing the logs. The logs becoming your kind of source of truth. You can recover state of the system by reading this log in a sequential order. You can use different tools to merge multiple logs, so you will have a full picture what happened in one service and what happened in another service. It's like a log aggregation. It was like a whole different line of business. But maybe you need to different type of log, so that allows your systems to communicate not only through perspective of this like login systems. So the record in this log reminds very much, like looks like event for me. Like, and what is event? It's something that happened. And something that's important for us, or important for us on given moment of time. Like sometimes we don't care about the info messages, but sometimes it's good to know, yeah, all info messages are here, so it looks like we're good, we're in the right place. And so event is a combination of a notification when we need to send some of the data and saying, hey, I'm done, some of the jobs finished. Or there's some of the data transfer. We're going to be using this, the pattern today. We're going to be using the both notification and state transfer in our demo app. Events are immutable. Like once you said something, you cannot change it. It's like in real life, you have an argument with your significant other. You said something that you're not supposed to say. Only thing that you can do is send another message and make sure that the receiver side will process this in time, so you will get good thing in life. And one is like abstraction point. In databases, we're using tables as our abstractions. In Hadoop, we're using files because it's a file systems. And in this like a log, actually there's a system that can do the things in the log system, in the log fashion. It's a system called Kafka, and in Kafka we're using log, which brings us to the point that I wanted to show right now. So I promised there would be no more slides, and now the rest of the stuff is demo. So now we need to bring the Kafka into the mix. So Kafka is the system that will combine, or like allows us two services to integrate. What kind of services we have, Anton?
We have basically one service, right?
We have two services. We have a driver service. We're going to be showing you some demo today. That demo will be kind of like an emulation of some functionality of ride sharing. So there will be some of the rider who wants to have a pick up the car, and there will be a driver who will see there's a rider, and we can go and pick him up, so, or her up. So in this case, we're going to be using this system. So I'm going to be using this in the cloud, just simply because it has a nice UI. I can show you all the bits that are flowing into the system, rather than I will be doing this in the console. You know, we programmers want to see the console, but sometimes the showing some of the bits of the application would be useful. Yeah, let's just call it Kotlin webinars. To connect to this, I need to use those things in our application. So now I'm switching to my screen. Folks in the chat, in the comments, let us know if you're able to see this nice, and you can see those things. Let me see. Yes, exactly. We're doing the Uber. We're coming for you. We're writing the killer of the Uber app today. So couple things. Let me put this in my configuration. I have a Kafka driver, depend on this key. I will put this key here. I will explain what does it mean in a second once I will show you this one. And here, okay. And in this case, I will say select configuration. It's going to be Kotlin. This is our API. This is our endpoint. So the Kafka has multiple components. One of the components is a server-side broker. The that's weird because it's supposed to be different, but hey, we'll see how it goes. Boom, 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 boom. Okay, so we're good. Support. So let's see. We have a topic. So the information of this data of our system will be flowing through the Kafka topic. And the Kafka topic, we're going to be using two systems. Since we're using these two services, one service will be using rider or driver app. So we're going to be doing this with them. And it's a Ktor application. And in this application, we're actually using a couple interesting things. So let's take a look on first configuration. We have this driver. Or should I run it first? Let me run this first, so the people would start seeing things, and after that I will go and do explanation. Just in case if we need to do some debugs, I will run my driver app here, so you folks will be able to see. Okay. So my application just started. It just prints out some of the WebSocket things on the screen, but actual thing is happening here. So it is a map. I see my driver here on the map, and there's a couple of things that this application already did. Yeah, of course. I forgot to change that like as we discussed this yesterday. So we'll bring this in a second. So this application will connect to Kafka topic, and this application will have two things. I have this application module that has all the common things that our application will be using. We have web jars that Anton just explained. So we're using web jars to bring some of the dependencies from like Vue framework, like some icons. We're using the web jars to do this. We enable a WebSockets to provide the server-side push. Anton, can you share the repository with examples for folks?
Oh,
they were asking.
Sure.
Yeah,
sure.
Yeah. So the Anton will share this in a second. Yep. Next thing is that we have a WebSockets, we have a WebJars, and now we have this Kafka. So you see, there's a cool feature that you can do install Kafka, where you can provide configuration to your Kafka. So since I'm running this in the cloud and I want to have a higher level of durability of my data, my replication factor needs to be not 1 but 3. So in this case, those things would be very durable and stop and rerun, and those topics will be created successfully. So meanwhile, you will be able to see this repository at Anton's GitHub. You can find this there. So just go in this there. So while my application is running, there's multiple things that happened already. So first of all, this application connected to my supposed to. Yeah, so my application is just connected to cluster, and using this Kafka feature, it was able to create the topics in this cloud. So configuration file that we use here, the Kafka driver conf, includes information to connect to cluster. It's just like some of the security information, and next it has some configuration that our application will be using to produce and consume data. Also, this information about connection will be used by a thing called admin client. And this admin client will create our topics. Why we need to use these topics? Because we have a second pair of our application. In our application, we will do debug, and we will start Rider, second application that have to go and connect to cloud. Now I have driver. Let me put this side by side so you will see what is going on there. I will do another thing here. Let's put this on other side. Just do Rider. And now I should be able to see the Rider. So as a Rider, I need to go somewhere. So I'm going here. So say I want to go to New York. I want to go in New York. It's a Flatiron building. I want to go here. So now my driver will see a pointer on the map where my user is. Supposed to, right? Let me quickly refresh, and we will see if it's there. Sometimes when we're working with front end, fun games. So as you can see here, on a driver's scene, I just push this notification from the client, from the front end. So I can go here in my driver screen, click this, and I will go to pick up this user. And now, as you can see, two screens now synchronized, and both driver and rider will see ATA. And this thing is happening in real time. So essentially, from here where I am to get to Manhattan will take roughly 30 minutes. So at the end of this presentation, we should be able to check if this thing will work. But so what we see right now, if I would we will show you what is happening under the hood. We do have two topics in our cloud. So the information about the driver, where is it? Will be pushed inside a topic about the driver. So location and status of current driver will be pushed there. So we know the coordinates of this guy, and seeing that current status is pickup, meaning that this guy is going for someone. So for how driver would know this, where to pick up. So driver is actually reading the data from rider topic, and we'll see this in a second. Partition number 1. So since it's a partition number 1, I can reset from the very beginning. Kafka, it's not only messaging system. It allows me to travel back in time, so I can like figure out from the very beginning, like where the data is. So partition number 1. And this is all history for a writer. Like everything that the writer published here is of. I will go to offset 0. It's a very beginning of history of my writer, and I know in the very just give me start from the very beginning. Application started. Come on, my UI is breaking. What? Okay, let me make it a little bit bigger. So what I wanted to show you here. Just let me download this, and we'll be able to see. Looks like UI just like froze a little bit. We say it in the JSON. And if I will go and say C downloads, what's the word? Messages, writer, and JSON, GQ. We can see nice things here. So when my application just started, my writer post a message on the Kafka topic that says that I'm available, and it put his current coordinates. So when my writer was appear on the screen, my driver will receive the message that there's some of the writer will be available. So when I click this, I will be able to go and come to pick up. So that's why we need to have two Kafka topics here. So next thing is that this is some of the assets. We will talk about this in a bit. But the important thing here is a WebSocket part. So if I'll go to this extension part, where we put all the code for these guys. Not anymore. So we have this endpoint, and every application. If I will go and show you this inside the network, I will be able to show you. Let me remove my debugger points here. Like each application will publish some of the data into WebSocket. Okay. So I need to refresh it. I don't want to refresh it because it will kill the current progress. But essentially, each application has this JavaScript code that will be constantly reading current coordinates and will constantly pushing this into WebSocket. From WebSocket endpoint, we have this Kafka consumer that will be reading this data, and so we have a Kafka producer that will be pushing the current coordinates into a topic for driver. It's going to be driver topic because it will be pushing the driver coordinates. And for the consumer, it will be reading coordinates for the writer. So the both screens will be synchronized. So that's how it's done. It's pretty simple pattern. So essentially, we use the two topics. One is producer to the topics, another is consumer to the topic. And after that, we're reading this data and displaying this on the screen. So always leave the code in a better state. Yeah, It's in a great state. So if you can go there, play around, it should be in a good state. How you can get the access? How you can get access to the topics dashboard? So this is something that available for everyone in Kotlin Cloud. So those things right now, my Kafka deployed in the cloud, and my data is in the cloud, and dashboard is also in the cloud. So there's two topics. One topic is driver. We have a driver produce data, and writer will read this data. In the same way, we have a writer that reads data from the writer topic, where the writer will produce this data, and this data will be consumed by the driver. So that's how it goes, and this is a fairly straightforward. However, a couple things worth to point out. So in this project, we didn't separate those two UIs in separate projects, even if we could. Probably it's a good idea to do this, because we have to overwrite some of the bits that are available in Ktor, which we appreciate, because the Ktor gives us flexibility to do so. Like we can have a custom configuration file for Kafka configuration. That will include some of the things that maybe currently is not available, so we will be able to do this. Next thing is that we use Kotlin X HTML DSL to generate our a front end UI, the front end bits. And this was also fairly nice. Previously, I would use something like a TimeLeaf or some other server-side the templating engine. With the Kotlin DSL, which is just simple code, which is simply injected this variable here, and access token that comes from say application configuration will be embedded into response. So which is pretty cool. And as you can see here in our configuration, for driver configuration, we have one module that has some common functionality. It will start WebSocket. It enables the WebJars assets and things like that. The same thing will happen for writer. The only thing that they different is the logic for frontend, like a JavaScript side for driver and the JavaScript side for writer are different. So that's why those things would be different. Should we see data for writer? Yeah, so we can start. This is basically our flow of our application that we can do. So what questions do we have, Anton? Let's talk to our.
We had some questions regarding RSocket integration in Ktor. I think it's not a problem if there is no integration out of the box. Ktor is very minimalistic framework. Basically, you can use any library just directly from your code. That's kind of a point of micro framework. Yes, Ktor provides a list of different integrations out of the box called features. So that you call install method for the feature, and the feature adds some kind of functionality into your application, and that's what we did with our Kafka feature.
Yeah.
Not that we actually needed it, but it was cool to create it, and it just shows how flexible the framework is and how easy it's to do. Viktor will probably show this feature a little bit later.
Yeah, I can show it. Where is it? It's in our.
It's in Kafka package.
No. I want to show how we used this before and how we. It's an application. Sorry, yeah, it's an application. Once again, so why we did this? There's a couple things that a good developer needs to take care of while we're using with Kafka. One of the things that I don't like when the people do this is to hard code their property files. For example, to configure Kafka, you need to provide this the property Java util property class, and sometimes people just like go and hardcore this value. So that's why it would be not very easy to modify if you need to move to different environments. So I wanted to show this how you can create a it's not even framework. It's just like how you can create the good piece of functionality that allows you to move to different environments. So essentially, our Kafka configuration allows us quickly just like disable all these kind of things and switch to local deployment that we will use like either Docker Compose or test containers, or all this kind of stuff. Without changing the code. So this was a configuration-driven development. Another thing is that I think the creating some of the additional configuration for our application is also responsibility of Kafka developer. If you're developing the system, developing service, you need to make sure that your topics will be created there with right configuration. So that's why I thought the having the feature and having this kind of sort of like, if you can see here, it looks like a small DSL for our topics. We have 2 topics, and just like in our Kafka feature, we have a configuration and the list of topics that I want to use. It would be great to use this. This thing is very straightforward in a sense. It's just like we take this block of configuration file and pass it here. So we will be able to do the configure of our system. In this particular case, we're using this Kafka admin API to create this topic. So this is admin client that it's an API that comes with Kafka. We're using this one. We're using the information that was provided through configuration in our configuration block, and after that we pass this into this create topics functionality that's available from Kafka. So, and for a consumer of this code, for sorry, it's application.pt, for consumer, for person who will be using it, it looks very straightforward. So the similar ways we're using this for other things, including the some of like WebSocket configurations and things like that. We do have this configuration in one place, and after that, inside our particular module, we're only using this. So I think it's a pretty good powerful feature.
There is a good question about using Kotlin DSL for HTML instead of any other templating engine. What do you think? I think it's nicer when you can check your syntax with the compiler, right? I don't see really any other advantage of using it.
There's a few. So first of all, you might be more flexible on what you want to do. Sometimes many organizations you need to go through the approval process. If you want to bring some of the new technology, there would be some security assessment needs to be like, because we know that the Java templating engines are huge security risk. We remember like a couple of years ago with the Equifax hack, someone used not the JSF, they used the struts, very old version of struts. And some of these templating engines, they're smart enough to just like simply bring in some of the malicious code in a runtime. With this, you will still have a templating engine. You don't need to bring the family in law with this framework. Just simply do one simple thing. And it will just work. There is a question about how to do like a caching and all these kind of things that are available in other things, right? So since it's a code, it's already compiled, it's already very fast. It doesn't need to do anything with compilation. So it just like return whatever string is available there. I think it's okay to use this code. It's just like a matter of taste. It gives you like a ability to do things, but not necessarily you need to use this if it's there, right? The Kotlin, Ktor has integration with at least like 3 different or 4 different templating that available out of the box. If you do like a start.ktor.io, you will be able to enable time leaf. You should be able to enable some other things. Let's take a look.
Velocity, free marker.
Yeah, exactly. Velocity, free marker, all these nice things. Struts. Oh, sorry, I typed this wrong. Ktor.io. And I can say, yeah, template. There's the HTML DSL that we use. There's a free marker, velocity, mustache, and time leaf. Yep, that's great that we have all these things available. Maybe the struts for Ktor. Like, and it's what I like about this. Sometimes like I was a little bit frustrated because some of the functionality was not there, but it was very easy to add. Like I was very accustomed to things that Spring does, so that's why I brought some of the ideas how the Spring integrates with Kafka into this demo with Ktor. So yeah. Meanwhile, this application still running strong, and our driver right now inside the Lincoln Tunnel. The reception inside the tunnel would be, maybe not very good from GPS, but hey, that's what we do. Another thing that we didn't explore but we wanted to explore is the testing capabilities. That's something that we can do specifically by adding like a test containers for testing Kafka. We already have this Docker Compose thing, so you can run this like locally. There's a documentation that you can find. You can run this locally. Only thing that you need to have is to just run this in Docker. So what's the? Do we have any other questions, requests?
I think we could take a look at this WebSocket part that we were struggling a little bit while implementing this functionality.
So inside the WebSocket part, there's a couple things here. So we do have this extension.
But the first thing was that WebSocket integration in Ktor is not taking advantage or not making use of content negotiation feature. So it only talks to you in text, and you cannot automatically make it to convert text into JSON. So you actually have to write code to convert it to JSON if your API requires that.
So essentially,
this time we were using.
This is block that Anton is talking about.
Exactly. So we were using Jackson in the beginning, but Jackson API is blocking. So when it parses the text into the JSON, the API call is blocking, and the ID will tell you about that. Hey, you actually have to defer it into a coroutine context. But here we are using Kotlin X serialization API, which is a non-blocking one. So therefore, it's actually simpler, and it doesn't produce this problem of blocking this thread for handling the incoming message. So and the other one was actually the problem with Kafka consumer, right?
Yeah. So the problem was here that we need to create the consumer only for current session. So essentially, when the application when you hit this application endpoint, we need to create the consumer, and after that, we need to close it and dispose it after the session will be closed. So that's why we're using this like finally block, where we need to once we're done consuming this. Our WebSocket connection would be off, and after that we need to destroy this consumer. Here it was kind of like a very interesting. I don't know if it's a race, because this is also blocking code. This code is asynchronous, so that's why we decide to move this around. So first we will serve HTML, and after that, like somewhere in the background, we will create this Kafka consumer. So there's still, I think it's not the problem of the framework or the problem of the developers. It's just a matter of like accepting some of the like asynchronous nature in more natural way in the Java applications, essentially, or like JVM applications, because the Kafka still has like a Kafka client still has lots of bits that they kind of sort of asynchronous, but they're doing this like asynchronous with like old school synchronous, like using the features, like completable features and things like that. Those things can be integrated. There's a integrations for reactive thing in Kafka Reactor, for example, to make this thing work. So yeah, that's what we have here. Now let's see if there's some good questions in the chat.
There's a good question regarding scaling the consumer.
Give me just a quick second. I will show this. All right, so the question is the previous answer. One more in the way. How do you scale the consumer guessing with the coroutine? So the interesting thing that the consumer in Kafka is you don't need to do anything essentially to scale those things. The consumer scales by number of partitions in the Kafka topic. So consumer, like if you have a topic with 3 partitions, we can have up to 3 consumers in one consumer group, meaning that those consumers will split this load. So it's not like you have one consumer that will get all of the data and another consumer will get all the data. In this case, when we start another rider, it will create a new consumer group for our application. So okay, so I'll try to explain this in the 2 words before our time will run out. The Kafka consumer has this ability to parallelize itself. So it's a built-in feature. You don't need to do anything about this. Yeah? If you want to scale this, you just start another consumer. You assign another consumer group ID. Kafka, say like driver. So we do have this like consumer group ID. So if I will start another application with the same consumer group ID for driver, they will automatically join and they will split the load. This is not what we wanted to have in this application, because we wanted to have only one endpoint will own one consumer and all topics, because all this data needs to eventually land into front end. So it will be like a straight like a queuing use case. In other cases, like if we do some processing, I've seen there was a question about Kafka Streams integration. At this point, we haven't tried to integrate with Kafka Streams, but I think it's a good challenge for some of the things that we are brewing with Anton, which is, I think, a good segue to talk about this. But in this particular case, we're using consumer and producer as a straight, for the straight messaging capabilities. Reading all the messages from one consumer from all the topics, and after that, push these messages into front end. So would you recommend Kafka? There's another question. Would you recommend using Kafka for PubSub for control local server cache in the microservice environment? It is a good question. I'm not quite understand what you mean by a local server cache in the microservice environment. I think I made the case when I explained this in a few slides, how I see Kafka will fit into this like microservice architecture and how it will allow to communicate things between two services. Definitely, if you do kind of like any PubSub type of thing, try if the Kafka will fit into your use case. Not quite sure. Before we disconnect, I wanted to, hey, see, as I said, everything was in the real time. We have this like a real-time application. Our driver came to pick up our rider, and it will take him to home. So from New York. So the application actually worked, and now when they met, we can start doing some other things. Before we part for today, I wanted to show something for you, and I want to invite that to something that we're brewing with Anton. So the next, not the next week after, on the March 30th, I would love you to join me and Anton in a hands-on workshop where we will be, you can join us. You can join with your laptop. You can join us with your
mobile, whatever.
Yeah, so whatever you want to use for writing your apps, please join us, where we're going to be teaching you how we can start with some of the basics of this. We start with the plain project on Ktor. We're adding some Kafka functionality. We'll show you how you can invoke the Kafka producer from REST endpoint. Essentially, we wanted to breaking down this application for you, so you will understand how you can use Kafka in Ktor. And we'll show you how you can use consumers in your WebSocket. We will talk a little bit about serialization and all this kind of stuff. It is going to be a free event. Only thing that you need to do is just to register, so we will know how many coupons you need to get to connect to Kotlin Cloud. Apart from that, I want to say thank you everyone who joined us today. Demo is published. This video will be available. My contacts and the Anton contacts you probably can find anywhere on the internet. If you can find us anywhere on the internet, meaning that we doing some of the bad jobs as a developer advocates, right? So people need to find the ways. Oh, we do have this the Twitter accounts in our screen.
Exactly. So thank you everybody for coming. It was a nice session. It was a very cool demo. Your homework is to go and download that repository and play with the code. Try running Kafka locally. Maybe you can create an account in the cloud and try Kafka in the cloud as well. Stay tuned for the announcements. We are going to plan more webinars soon in springtime. And, let us know, what did you like about the webinar so far? What kind of things you would like to hear about more? You have to write in the comments, you have to write in the chat. If you can tweet about it, it would be very nice. Subscribe to the channel once again. I just reminding you. By the way, Viktor has a very good channel as well on YouTube. If you go to and find it, by Confluent keyword, I think you will find it just easily. There is a lot of interesting content and about streaming with Kafka and distributed applications. And thank you very much. And it's a wrap.
Yeah, it's a wrap. Thank you. As always, have a nice day.